Welcome everyone. In this video I'm going to talk about my coil winder project again. So this is the 7th part of this project, so sort of the 7th iteration of everything. And now I have some substantial update regarding the electric circuits. So I would like to talk about that a little bit. And I did some updates on the mechanism as well, so I would like to share some things there too. So as you can see, now we have the wall system assembled. On the left side you can see the mechanism, and on the right side you can see the wall circuit which drives the two motors. So one of the biggest updates right now is this circuit right here, because previously I was using a single microcontroller and everything was connected to it by wires and whatnot, so that was a really huge mess. To be more precise, that really huge mess is here, so you can see that this is not so good. And I always had problems with the testing because my table is here and my computer, which I use for programming, is in another room, so it was always a bit cumbersome to move this wall setup between my room and this table. And then I decided to basically design a PCB for all the circuitry and then assemble it. So this is the first iteration of this PCB, and I have to state right now that this PCB has a bit of a mistake, which I did. It works, but it doesn't work in a way that I want it to. So there's another PCB already produced and it's on an airplane probably coming towards me. So there will be a next part where I talk about the circuitry in a very deep details. Maybe I will show you how to design this, and I will also share all the other things. Nevertheless, since it works and it works properly, I would like to talk about the things. And then this brings us to the next step, to introduce the sponsor of this video, PCBWay, who is also the producer or manufacturer of this PCB. So PCBWay is a service provider specialized on PCB making and assembling, but they also have services such as 3D printing and CNC machining. So ordering a PCB from them is a really simple task. You just go to PCB Instant Quote, and then on this page you just click Quick Order PCB. So you can upload your Gerber file, and then you fill up the rest of the details to customize your board and press Save to Cart, and then you can order it. And if you are already experienced in PCB design and PCB making, I really recommend you to check out their 4th PCB design contest. They have 2 main topics, IoT and robotics, and you can also choose your own topic if you will. And as you can see, they have really nice prizes, so it's worth to participate in their contest. So I hope that you will like their services and you can use their services, especially for making this board or similar boards. And also you can find some parts on the mechanism which can be printed by using their services. So starting from the board, this is a 16 by 7.5 centimeter board, so it's a bit larger than usual. But as you can see, it accommodates a lot of parts. So without the parts, the circuit board looks like this. So this is the ground side or the back side of the circuit board, and this is the top side. You can see the silk screen, you can see all the parts and then the traces. And as you can see at this part here, we have a Nokia 5110 display. And I made the mistake with the headers. And what I did here is that I accidentally left it flipped. So now it's in a mirrored direction. So if I read the letters here or the abbreviations of the connections, then this is how the pins are settled in the board. And that's correct. So I mean, from left to right, we have first 3.3 volt and then CRK and then DIN and so on and so on. But if I want to put the display in with this kind of orientation, which is the normal orientation, so this is the top of the display and this is the bottom of the display, That's just wrong, because if I show you how it looks like, then in fact the pin out of this display starts in the opposite way if we mirror it on this axis. So you can see that actually we have the 3.3 volt GND and CS, which is like right to left, and here it's left to right. So then yes, I can put the display in like this, or even like this, and it works without any problems. But the library that I'm using with this microcontroller does not allow me to flip it easily. I mean, flip the text. So it's a tiny inconvenience that I just cannot use it in a proper way. So as I said, there is a new board. It was already manufactured and already shipped to me. So that will be another video where I show you the board in more details. And I will also show you what I improved as compared to this board. So what we have here, we have the pull down resistors, as you can see. We have the two buttons. We have a rotary encoder already embedded in a board. I recommend you to get like 10 of these because they are very handy and it comes with everything. So you get this cap for the knob and you get this in a board. And what is special about this board is that it's not only that it has a very good, let's say, conversion between these layout of the legs into a linear layout, but there are 5 resistors and 2 capacitors on this board, so you have debouncing and pulling up for all the pins, which is really nice. So you have less struggle with the rotation and the clicking. And then it's very easy, it's a linear layout, so it just goes in the holes like this. And then in the middle I have a microcontroller, and you might wonder what kind of microcontroller this is, because it has a black color and like this blue pill. So this is a black pill. It's an STM32F401 CCU6, if I'm not wrong. It's a bit different than this blue pill. In fact, it's better, but it has a slightly different layout. So this PCB is only compatible with this thing. But due to the chip shortage, these guys, one single guy is almost $10, $8 to $10, while this can be bought for $3 to $4, depending on where you buy it and so on and so on. But these are much cheaper nowadays, so I decided to design my board around this, and it works properly, so no problem. And then now I have 2 identical drivers for the stepper motors. So these are the DRV8825 stepper motor drivers. We have a big capacitor for each drivers on the power input part, and then 3 jumper pins on both sides to control the micro stepping. And then this circuitry here is an LD1117 based 3.3 volt voltage regulator. This provides the 3.3 volt for basically this side of the board. So it powers the microcontroller, the display, the buttons. Okay, they don't need power, but you get my point. And then also the rotary encoder. And then on this side, I have the connectors, and then they look something like this. So these are the terminals, this 5.08 millimeter leg distance. As you can see, this a bit more bulky legs for the higher current, and it's very convenient because you can separate these 2 things. So then it's very easy to use these screw terminals and just hook up any kind of stepper motor to the circuit. And also I chose the same for the power, but you can just directly put this kind of screw terminal there for the power, and yeah, it should work. And for some of the components like the microcontroller, I use this kind of jumper header. So I just solder these in the board. I will show you in a moment. Like this, and I have several of these things, and then it's easy to swap the parts if it's needed. So now, yeah, everything is in a single board. There are no cables, no wires, nothing. It's very neat and simple, and you can put this in an enclosure or just have it somewhere. The only thing is that you have to make sure that you cover the bottom, because on this part of the board there can be high power flowing through the traces, so you don't want to short the pins. But yeah, I will show you that this works, but let's jump to the mechanical part. So I upgraded a few things, and I also already tested winding. But first of all, as you can see, there is a corner piece inside here and inside here, which connects this now U-shaped or C-shaped, depends on how you look at it, this frame to this rail here. And previously it was this guy. So it's a simple L-shaped thing, and it was in the same orientation here and here. But the problem is that if I push this, it's not very noticeable, but there is a small springiness to it, and I can squeeze this a little bit. So when I try to squeeze the frame when it's assembled, it has a little bit of a play. And in the previous video, one of the commenters mentioned that these things have to be more stiff. So this is one step that I basically filled up this bottom part with a 5mm thick plastic layer and printed it again. So now they have a filled in area here, or I show it with my palm. So this part is filled in, as you can see it there. So both sides are now reinforced. And then another thing is that you might have noticed that we have the holder here attached. So what I did here is that I designed a new holder, as you can see, which is attached to this frame here. And then there is the M8 nut inside this plastic printed part. And this reel or spool holder is just simply screwed in this bolt here. And I printed the shape of the bolt as the hole here, but then I put a few drops of super glue and then pushed in this nut. So now it's there in a stable way. And it's not a problem if the feeder is a bit this side or this side, because we have a hole here for the cable or wire, to be more precise, and that guides the wire. So even if it comes from the sideways, it's not a problem, because yeah, it will be guided by this hole here. So this is the basically mechanical upgrade. And now I just want to show you that this thing works. And now I have to also mention that this voltage regulator cannot accept I think higher than 18 volts. I will write it down at the bottom of the video. So you have to make sure that you don't have higher than that voltage on your input, because the stepper motor drivers and the voltage regulator both take the same input. So now on the clips I have 12 volts and 2.5 amperes allowed. So I just turn this on and see what happens. So as you can see, it turns on and it works. I can navigate in the menu. And what I can tell you right now is that at 12 volts, my power supply here shows 1.015 amps, so 1 amps basically. So this whole thing now consumes 12 watts. And that I think more or less a reasonable amount, so it's not a high consumption. But what would be interesting is to see what is the consumption when the motors are running. So for that I have to get this wire back to the original source. I'll just move this so you can see it. So I have to put it back here. So I just do that thing, and we will try some kind of winding here. So I removed the wires, so now they are there, and as usual I started to manually wind 2 turns. So those 2 starting layer turns are more or less tightly packed, and hopefully the rest of the coil will follow. So I decrease the speed here, and as you know, I can do it by turning this knob, but I can also use the buttons, and the button does larger steps, so it's more convenient to quickly decrease the speed. So 800, that should be 30 RPM on this shaft. And 130 turns may be a bit too much. I have to wait too much. And I know that roughly 40 turns are inside one layer. So what I do here is I say 100 turns. So that should be like 2.5 layers roughly. And I know that the wire diameter, I measured it actually, and it turned out to be 0.365 millimeters in average instead of the 0.35 millimeter nominal diameter. And one thing that I have to change in this code is that I want to change the 3rd digit, but I just round this number up. Hopefully that will be fine enough for wire diameter. And everything else is left unchanged. And I want auto winding, so this will just go as long as I don't stop it. So let's see what happens if I start coiling, and it might go wrong, it might not. I was not preparing anything, so just let's see how this works. And meanwhile I can see the power consumption, and it's 1 amps still, 1.025, so that is sort of unchanged. And so far the first layer looks perfect, but let's see what happens with the second layer, because that is always the critical part in this winding procedure. So it's done, 100 turns, and a bit more than 2.5 layers, because 2.5 layers would have been if the thickness of the wire would have been 0.35 millimeters. So I can see that the winding is almost perfect. In fact, there is a little bit hiccup. I will take a picture of this, but that actually did not mess up the rest of the 3rd layer, which is really surprising, I would say. So what happened that when the 2nd layer was about to finish, in the first layer, in the beginning of the first layer, there was a little bit gap between few turns, and then the 2nd layer's wire, which was coming in this direction, fell in between those gaps. Therefore, when the wire started to go there, it caused some disturbance in the order of the layer. But in fact, it's not a very bad problem. I can see that it's not perfectly packed. You will see this on the picture, but it's good enough, I would say. And then the rest of the coil, after like 5 turns or 8 turns, it's just perfect. So I think that this, let's say, more rigid corner piece helped. It's still not rigid 100%, and probably I will try to get some more stiff structure, but it's quite good. I'm surprised. So seems like that this is working properly. So yeah, basically these were the things that I wanted to show you. The new electronics part and some of the new mechanical parts, especially the corner piece and this guy here, which holds this thing. And yeah, basically that's all. So as I haven't yet received and tested the new iteration of the board, I don't want to share this iteration because it's just not perfect. It doesn't work in a way that I wanted it to work. So let's just wait for the new board, and then I will show you how you can get this board and how you can get it manufactured by PCBWay. So that will be nice. And then meanwhile I will work a little bit on the coding. So I will also share the code in a future video. So you will see that probably together with this PCB board and with the plastic parts. So I hope this video was useful to you. I hope you found some information helpful, and I hope you learned something, and see you in the next video.